Hello everyone. Thank you for watching my previous video on most important chemistry tips in the research lab. So it will be my second part of the tips and I'm going to make more video on this kind of tips. I think it will be very helpful for the students and researcher, especially the researcher who is started newly in the lab, especially the new grad students who just joined in the research lab, started synthesis and organic chemistry. So a couple of important things I'm going to tell you now. First of all, when you start a new project synthesis having the multi-step synthesis part, so in that case, try to take the proton NMR spectra, carbon NMR spectra, melting point if the compound or intermediates are solid. So take the melting point and also the HRMS data if you have available. So this will help you in future to write your supporting information for the thesis or the research article. If you don't do immediately, sometimes you may forget or sometimes you may be think like being lazy, like I'll take it later, but there are some issues because in many cases compound can be unstable and this compound can change by degradation or polymerization, dimerization, by oxidation, or compound can be light or photosensitivity. So you have to be careful. That's why whenever you are making the compound, take those important data like proton NMR, carbon NMR, melting point, and the HRMS data if you have that options. Second tips you can remember, when you made any compounds or intermediates or final compounds by multi-step synthesis, so store at least 15 to 20 milligram of those intermediates or final compound in a small vial and store in a refrigerator having a individual box name, that specific project name, so your compound will not be mixed up. Because in your long time research time, like if you are doing PhD studies, so it will be like 5 years in USA or in any other country, maybe 3 years or something. So this is a long time, and in that time you maybe like lost your compounds in different boxes or different places. So in that case, be careful, always make an individual separate box, name that project, specific project, and store your final purified product in a small vial for your future reference or future use. Because when you write your paper, supporting info or paper or like journal articles, so sometimes reviewers made comment on your compound or like some analysis. So if you have some compounds in your stock, you can use those compounds for those reference or like for those use or purpose. So the tips is store your compound in small vials, label properly, time, date, everything on it, and then put in a separate box having that project name and put it in the refrigerator. That would be safe to do. Third tip, when you do the NMR, like proton NMR and carbon NMR spectra of your synthesized intermediates or products, final product, then do the process with the software immediately and try to export your spectra in a Word file or a PowerPoint serially, like by the date chronologically, so that you can easily find out those processed spectra during writing your thesis or like supporting information for your paper. So that will help you to get the data quickly. And also there are like lots of software that extract your proton NMR information, like how many proton, what is the splitting pattern, everything, especially the Mastronova software you can use if you, that is licensed software. But if you don't have, then if you want a free software, then you can use a Spinworks software that is free totally. And if you want to know how to process those NMR with the Spinwork, I have another video in my channel. You can visit that video, how to process the 1D or 2D NMR by Spinwork. And also I have another video on Masternova software, how to process your NMR data by that software. So in my channel you will get those video there, so you can visit those video. So so if you process those spectra beforehand, then it will help you to get the data immediately whenever you need it. So you can keep it in mind when you are making the when you are synthesizing the compound. So process it, store it in a PowerPoint or like a Word file chronologically. Another tip is very interesting and also important. So many of us who normally do the synthesis, organic synthesis, we normally follow the literature procedure, different literature procedure, like from their supporting information. So definitely you have to put reference while you are writing your supporting information, because that procedure is not made by you, so definitely refer them. So you have to give the reference for that procedure. But while you're synthesizing or making those compounds following that procedure, I would do just copy that procedure part, bring it in a Word file and change the modification whatever you have done for your own reaction, and keep stepwise chronologically. So it will help you to collect your that description during writing your thesis supporting information or the paper supporting information. So it is a good idea, like you can just take that language and you can compile during your requirement. So definitely you have to double check the language, like because different people report differently. So if you don't feel very good on that writing, maybe you can modify. But if you have this practice, like chronologically you always record those procedure also, so in future you don't need to write a lot. So just you can copy and paste one by one in your synthesis reporting. If you follow any procedure from any literature paper, so you should also write the reference style, that paper name, author's name, paper name, and also the year, volume, and the page number. And I'm going to show you here like how to write that. So it is a good practice to write, because you will definitely write your reference in your thesis or the paper. So normally the last name, different paper has different pattern how to write, but normally you can write the first name short, middle name short, followed by dot, and the last name is full, and then the paper names, and then the year in the bold font, and then volume and the paper page. You can see this example here I'm showing. For Suzuki Heck Nigishi Sonogashira coupling reaction, where palladium catalyst involved and solvent ratio is matter, then it must be done with the water condenser attached instead of the air condenser, because there are some options, like you can use the air condenser or the water condenser, like water flow through the condenser or air flow through the condenser. So definitely you have to use, if you are using the reaction in the flask with the condenser attached, definitely use the water condenser. If you use the air condenser, your solvent will be lost. So in that case, the ratio will be decreased and your product yield will be less. But in some cases, people use the freeze-thaw pump in a Schlenk tube. In that case, you don't need to think about the condenser, so that is okay. So in Suzuki and Heck reactions, or like Nigishi coupling or Sonogashira coupling reactions, there are lots of solvent can be used. Especially for Suzuki, you can use toluene, is a common organic solvent, and also 1,2-dimethoxyethane or DME as a common organic solvent. But in some cases, you can also use dioxin as a common solvent for the Suzuki coupling reaction. But in some cases, you can also use THF and water mixture, depends on the solubility of your starting material. So if your starting material is soluble, not soluble in DME or toluene, but soluble in THF. So in that case, you can choose THF and water for the Suzuki reactions. For Suzuki coupling reaction, normally boronic acid works better, but sometimes it may not work because of the solubility, because the boronic acid has 2 hydroxyl group. So in that case, try with the same counterpart with boronic ester, not acid. And there is a benefit of making ester. If you have the boronic acid, or if you make somehow boronic acid by Grignard reagent, by using Grignard reagent, or like lithiation and the borate trimethoxy borate compound, in that case you will have the hydroxyl group, and it will be difficult to purify through column chromatography, especially with the silica column. But if you can make the ester, it is easy to purify through column chromatography, like silica column chromatography. So in most cases, boronic ester give a better result than the boronic acid because of the solubility in the solvent. An easy way to make the boronic ester, if you have a bromo compound or iodo compound, especially the bromo compound, you can easily make the boronic ester by using bisphenolato borate in presence of palladium DPPFCl2 catalyst and high boiling solvent as a dioxin, 1,4-dioxin. It is very common method. Just mix everything together, degas it, and heat it up around 100 degrees Celsius. Run the reaction like 6 to 12 hours, the clean reaction. You will get the boronic ester in the position of bromine. So, and you can use this boronic ester for the Suzuki coupling or any other coupling, especially the Heck coupling, Suzuki coupling, those requires the boronic ester or boronic acid. And it is easy to purify it through silica gel column chromatography. So till now, these are the common tips I am giving, and I'll bring another video with more tips for your research lab. Hopefully that would be more better. And if you like this video, and if you want to see more common tips and techniques in the lab, please subscribe my channel and stay tuned, and I'll be bringing more organic tips and organic reactions mechanism, many other video. Thank you for watching my channel, and thank you for all of your support for growing up with my channel. Bye now.